Hello, this is Dr. Kristen Mandello, and today I'd like to talk to you about pharmacovigilance, signal detection, and data analysis, and specifically eNov's solution, PV Analyzer. You have the data. Let us help you proactively identify early alerts and manage your product's benefit risk profile. You know, since 2012, there's been a greater emphasis for the marketing authorization holder to establish and maintain a comprehensive signal strategy over and above the underlying obligation for single case and aggregate reporting. It's no longer enough to simply capture adverse event information. Now, the MAH is expected to support a risk-based approach using globally available data across the entire product lifecycle. Both clinical and spontaneous adverse event data should be incorporated along with information from other relevant sources in this approach. Both internally and externally among health authorities, this information should be proactively reviewed, analyzed, and used to identify signals of disproportionate reporting, as well as indicators of potential patient risk. This expectation is evident as critical and major findings and inspections related to a lack of sufficient signal detection have been reported. Here's where PV Analyzer comes in. eNov's PV Analyzer offers a great potential for your company to integrate a feature-rich, easy-to-use statistical analysis platform into your pharmacovigilance program. PV Analyzer can be populated with case data from standard E2B file formats, as well as data from other sources, such as background data that can be derived from FDA's Open FDA initiative, EMA data, or other internal sources you may have. The application is designed for out-of-the-box use by business users and offers a broad array of statistics, including reporting odds ratio, proportional reporting ratio, EBGM, chi-square, just to name a few, as well as powerful data cubing and visualization functionality. By being able to run fast and efficient reviews of adverse event data, you can quickly and routinely examine the data set for potential signals that may require further evaluation. And when you find an interesting signal, the system automatically sends it to the eNov PV Signal Manager for further evaluation and prioritization, and action if needed. Now, let's take a look at PV Analyzer to see the system in action. You will notice the excellent performance that allows you to drill down into your data, visualize outputs, and generate signals quickly and easily. If you would like more information about PV Analyzer, PV Signal Manager, or any of the other PV solutions from eNov, please contact me after this brief demonstration.
Hello, this is Nick Pillinger of eNov PV. Today I'm going to be giving you a demonstration of our PV Analyzer software. PV Analyzer is an application used for signal detection. It runs on its own database, and the reason we do that is because we can populate that database with a routine extraction of pharmacovigilance case data from our own PV system, or we can populate the PV Analyzer database with cases that are imported from a third-party provider's PV system, and we can import those case data in XML format or any other standard format, load them into the database, and then they're available for signal detection activities. The other reason we use a separate database is because in PV Analyzer we're thinking about our case data not as individual case reports but as product sign pairs, and we're going to use that product sign pair information to look for potential signals in the data set. We're also able at the time of the extraction to normalize and rationalize our data so that we can make sure we're using standard consistent vocabularies, and we're also able to ensure that any differences in MEDRA or VEDRA versions are upgraded to a consistent dictionary version. And we're also able to consolidate data like ages and weights into common sets of units. So even if the original underlying case data for patient age is entered as years or months, we're able then to record that and display it within the signal detection tool as a set of consistent units. Let's start by looking at a function in the PV Analyzer system that allows us to query the product sign pair data that we have. And in here we have a left-hand menu that has a series of different queries, and these queries are grouped together into different functional blocks. We're going to start off by looking at this product signs blocks, product sign block, and in here we have a number of different queries, and these queries are themselves configurable. If we run one, we're able to select specific parameters and find case records that meet the conditions that we define. And I'm just going to pull back a variety of data to have a look at. We then return our data in a results grid, and this results grid shows each of our product sign pairs, and obviously an individual case may represent multiple product sign pairs if it contains many suspect products or many individual clinical signs. We expand that case record out into multiple rows. So this case record here has multiple rows presented to represent the different product sign pair combinations. These grids are very function rich. We can move columns around to change the layout of the grid. We can actually access a column chooser and get hold of any different columns of information that we may want to drag onto the results grid. And you'll see in here the things like the age in months. I mentioned the normalization of the age units. We can also sort our data, and we can filter the data by using these column filters at the top here, or we can group our data by dragging columns into the header bar, and we can show the individual product sign pair records broken down by whichever columns we choose to group by. We can actually add into the display results, we can add these footers that show us either counts or some average records for that individual column of information. The next thing we can do from our grid is we can actually select cases and push them into a data cube. When I open the cube, I'm first of all presented with a blank canvas onto which I can construct a data cube. And in here at the top of the screen, I have a variety of different data fields that I can use within the cube design. And let's take, for example, I chose to look at the product generic. If I take the generic column, I can add that to the axis down the left-hand side here. And then if I want to look at the number of records that I'm actually seeing, I can pull a value into the intersection here. If I just make these fields a little bit wider, you'll be able to see that I'm looking at the count of records for each generic product in the data set, and I have a grand total at the bottom as well. Now these are sorted actually at the moment in alphabetical order by generic, and I can change the sort order there. But if I right click on this column, I can actually choose to sort the results into the generic that is reporting the most number of product sign pairs in the query results that I was looking at. So maybe I want to look at another axis, another dimension in the data. So I can pull, for example, the quarter in which the record was reported, and I can now see my generic information broken down by the quarter in which it was reported, first, second, third, or fourth. Obviously, my data is still sorted according to the overall incidence of generic, but if I wanted to sort the information to see the most commonly reported generic within the first quarter, I can change the sort criteria accordingly. I may then want to add another parameter to the results grid, and let's take, for example, the system organ class, and I choose to record that or look at that against the generic. We'll just expand that column there a little bit so we can see the system organ classes that we're looking at. I now have a breakdown for each generic by system organ class by quarter with the counts displayed on my results grid here. Once again, we may choose to change our sorting, so I can look at the most commonly reported system organ class within each generic. And obviously I've got lots of generics in here which are reporting just a few signs each, and I may want to hide those from my results set. So I have the ability to run a top N, and I can use this to look at, say, the top 5 most commonly reported system organ classes for each generic. And if I do that, not only do I just see the top 5 system organ classes, I actually see a 6th block, which is all of the others compounded together with a total for that set there as well. We do have the ability to apply a reporting rate, and that allows me to see these numbers in decimal terms, so I could see them as a percentage or convert them to a percentage. I can turn that on and off as I see fit. Obviously, again, the system allows me to export the data at this point. So if I wanted to export these cubes of information out to Excel, I could do that. Or I may want to use PV Analyzer to generate some visualizations itself. And I can do that by selecting certain fields or certain cells of data. So for example, the number of times a particular system organ class has been reported with the Alpha Cream product, and I can choose to generate a graph, let's say for example a bar chart. That will then show me a nice bar chart with a code key at the top here for the individual system organ classes that we're looking at. I can choose to enable the labels on there, and there is also a chart wizard that allows me to customize this chart further, change the colors, change the appearance in many different ways, add titles, add other labels, and again I can export these charts out to a format that I could use in a presentation or any other document as I see fit. If we wanted to look at data in a different way, so for example I choose these cells across the top here and we choose a different chart type, we can look at a pie chart, for example. So this is showing me the breakdown by quarter for the systemic disorders associated with Alpha Cream. And actually if I select multiple blocks in my cube data set here, I can see multiple charts in one go for a number of different system organ classes, again broken down by quarter. And once more I can use that chart wizard to customize that further. Another feature of PV Analyzer is our statistical calculation engine, and we'll go and look at the statistical calculation next. And I can go here to do that, and to show you this I'm going to talk through the process of setting up a new calculation. So if I select the new button, the first thing we do is give the calculation an identifier. So we'll call this NJP demo number 1, and I'm actually going to put that same value into my description field. Then what we need to do is define the product sign pair records that we consider to be our source case set. So first of all, we have to say which cases we want to look at, and we can limit our cases by date range. We can limit our cases by different problem types. We can say we want to look at a particular geographical area or any other filters that are established within the system. We then have to say which products we want to include in our overall case set, and I'm going to use all of my data as background information. So I'm going to include all products and I'm going to include all signs. At the moment in this system I'm using my own case data as background denominator data, but it would be possible to load into the system some external source, so OpenFDA data for example, and use that instead as the denominator data. The next thing we need to establish in setting up a new calculation is which specific products and signs we're interested in. And now, of course, you could do a very broad analysis, selecting all company products and all potential signs as your targets, and that's perfectly possible to do that as a sort of speculative analysis of your data to see what potential signals exist in the statistics that are generated. Or we may be looking for a particular set of products and a particular set of clinical signs. And that's what I'm going to do just to start off with. So I'm going to use this grid here at the top to find the products that I'm interested in, and I'm going to do that simply by grouping by the generic, opening up a particular set of products and then add those to my selection list. So these are the products for which I'm going to generate statistics. And then I'm going to select my signs, and again I could choose all signs or I could limit my results a little bit, so I will do that. I'm just going to look at application site reactions for the products in question. And then finally, the calculation options. This allows me to look at expanding the results that I generate based on whether there are interacting products or not, and whether those are non-company or company products. And also we can set up other stratifications here, and importantly we have to say what level we would like to see our results generated at. Now, you saw me select in the target products a single product generic and a single system organ class. If I actually chose generic and system organ class as my results level, then I would expect to receive one set of results. If I choose to look at my data by brand and system organ class, then I would expect to get a set of statistics for each brand that belongs to that generic for which I have one of these signs that belong to the system organ class I selected, the application site disorders. If I choose brand and low-level term here, then I'm going to expand my results set to cover each combination of brand and low-level term that exists within the boundaries that I've set, so within that generic and within that system organ class. For each combination that exists, I can expect to receive a statistical result in my list. If I apply additional stratification, effectively what that does is it multiplies that set of results by each banding within the stratification. So if I chose to stratify by the patient's sex or gender, then I would expect to get a result set for male patients and a result set for female patients. And that's for each brand and low-level term. And that will then allow me to look for statistical differences between the stratification levels that I've set in this section here. But let's just run it first of all without those any further stratification applied. And we can also choose to include EBGM calculations as well if we wanted to. Let's ask our system to run that. And what the system does at this point is it basically prepares the data, and what it's doing there is it's looking to see how many brand low-level term combinations we've got. Once we've done that, we effectively queue that calculation up, and it will then run in the background. So I can carry on using PV Analyzer whilst that calculation is performed for me. If we actually go and look at this list here, this shows me a set of calculations that are ongoing, and if I just refresh this list, we should see our calculation is actually executing in the background. If I just refresh again, it shouldn't take very long to complete this one. There we go, it is now showing as 100% completed. And from this screen here, I can actually go and open up the results of that calculation. And we'll see on our results screen, these are, if I look at the, again, we've got a grid of results. So each row in this grid is an individual set of results, and it's listed by the product description. So actually it looks like we only really had one brand that had any data within our generic, and these are the individual clinical signs that are present within that brand. And if you look at an individual line as we walk across, you'll see there are various columns of information. So some that just really describe what it is that we've run here. If we keep going across, you'll see we come to start getting some numbers here. So we see the A counts, the B counts, C counts, and D counts. And then from those, we've been able to calculate things like the PRR, the IC values, ROR, and there are a wide range of other statistics as we move across, so chi-squared, and various other things in here that would be useful in examining the significance of this particular product sign combination. Now, of course, you can look at the absolute numbers here to try and determine the significance, or perhaps more usefully, you can set a series of thresholds, and those thresholds can be defined via a configuration screen. And on this screen here, you can actually set custom thresholds using individual statistical measures. So I've set a very simple one here. My own threshold of PRR is I'm looking for situation where there are more than 3 records of a particular product and sign. Effectively the A count is higher than or equal to 3, and I'm looking for a PRR value greater than or equal to 1. Once I've established that alert, or as many alerts as I want to, I can actually then apply those alerts to the results grid, and this is the alert that I've established. And using the functionality of these grids where I can group the information, I can simply group my results set by that alert. And if I do that, I can see those records where the alert is exceeded and those records where the alert or the threshold is not yet met. So I may then choose to investigate or to explore a little bit further these values here that exceed the threshold that I've determined for myself. And of course, one thing we would like to be able to do here is actually manage the investigation of that interesting result that we've achieved, that potential signal. And I can do that by selecting the items that I want to manage and want to investigate, and I can push them to our Signal Manager tool by clicking this button here. The system will make a connection to the Signal Manager tool, return the fact that we have successfully pushed those across, and actually if I apply the column to the grid, if I look in my list of columns that I have available to me, there is actually a column called Signal Manager Link, and if I look in here, you'll see that both of these signs, the signal calculation results that I've generated here, have a link that I can click to take me across to the Signal Management tool to look at the progress of that signal investigation.